In this video, we're going to talk about how to make a basic assignment in C and what that really means as far as memory is concerned. And through this process, we're going to be issuing statements one after the other, which is the very definition of the first of our three pillars called sequencing. So sequencing is a very simple term. It just means do one thing after the other. That's what we're going to be doing. So we're going to talk about basic assignments and sequencing. Okay, for this video, what I want to do is begin with my HelloWorld program, because I want to do a little bit of description on what I consider templating to save you time and effort. Okay, and there's also one thing that I wanted to talk about as we move forward, and that is the returning of a value to the operating system. If I don't specify it, it's going to default to returning 0 if the program ends, but it is always a good idea to explicitly return the value in C, so that I am saying, no matter what, I want you to return a 0 when you get here because we're done correctly. So I'm going to control save that. And what I'm going to do is I've saved that as Hello World. I'm going to, let's move this over here. I'm going to clear this stuff up from the last time, and I'm going to say make hello, and then I'm going to say /hello. And it still works fine, so I haven't messed it up at all. Okay, hello world, so that is my hello. But the thing I can do is I can say file, save as, and I can call it template.c. Okay, and now this is going to be keep the current version. This is template.c. Okay, and I'm going to change this to insert program name here. Okay, and I'm going to take this out. Okay, and I'm going to save this, control save, as my template. Now I'm going to close all my files, and I'll clear this up. Okay, so if I open up template, I now have this blank setup shell of a program. And all I do, because the next program I create is going to be called assignment or assign, so I'm just going to say file, save as, assign.c. Okay, and now it's called assign.c, and you'll notice it showed up here as well. Now I don't need to compile template.c because it doesn't do anything. Okay. Now, because I'm working online and I've gotten bitten before, I tend to close these things and then just go back and reopen assign to make sure that I'm definitely working on this and there's no caching that's messing me up. So that's just a little habit I've gotten into because I've seen some quirks, and I like my terminal to be on the right. All right, so I'm still in my school directory, so if I ls, now you'll see I've got hello and the executable. I've got this template that I can use over and over again, and I've got assign.c. Okay? So now let's jump into assignments. So the first thing I'm going to do is say simple assignments showing data types. Okay? Now one of the things that you're going to notice as I go through this is we're really going to cover data types, but we're also performing the first of the three types of controls that allow us to build any program, and it's called sequencing. And sequencing is nothing more than doing one step after another. So as we go through this, we're going to do a bunch of steps in a row, and that's all there is to it. Okay? So here we go. We're going to start with the integer types. So let's leave ourselves a comment and says integer, let's say data types. Okay? Now we're going to say int x equals 4. Now, believe it or not, I've done an hour-long lecture on that statement right there, int x equals 4, because there's a lot going on there. What's happening is the compiler sees int and it says I need either 2 or 4 decimal places based on the compiler, and I'm going to make that a comment here in a minute. And I want those 4 bytes that you give me in memory labeled X, so that I know that when I call X, you're going to go to those 4 bytes and give me the value that's stored there. and this is the left-hand side of this guy, which forevermore in my classes, you call it the assignment operator. That is no longer an equal sign. It is the assignment operator. It does not test equality. Okay? This is the assignment operator. I want you to think of it as having a little arrow on the left side of it, because what's on the right is evaluated and stored in the location on the left. That's how this works. Okay? And that is an assignment. So the value 4, and since 4 is literally a number, that is called a literal. It's literally the number 4, is going to be assigned to the location in memory that is either 2 or 4 bytes long, named X. Okay? And what I'm going to do out here is put a comment that says integers are either 2 or 4 bytes depending on the compiler. All right. Then we're going to print it. So we're going to say printf. Okay, and we're going to say the value of X is, and now we need a placeholder where the print method can stick the actual number. And we have to tell it the data type of what it's going to put in there. So we're going to use %, which means placeholder, D for digits, okay? And then we know we're going to need that /n or it's going to look silly. Okay? And we're going to finish the quotes, and then we're going to put a comma, and we're just going to put the variable x in there. So what that means is it's going to say %d, I'm looking for a number. So it's going to go out to my list of comma separated values that come after the string, and it's, oh, there it is, that's x. So if I said the %d value %d of x %d, it's going to look for a bunch of variables or numbers strung out with commas after them, and there needs to be one variable or number for every placeholder that there is. And you're going to see these as we go through, so they will get easier to understand. And now I'm going to do another one, printf, and I'm going to say, for this compiler, the number of bytes used in an integer is, and I'm going to say %d again. Actually, for this one, I actually need a long, unsized integer, or the compiler won't like it. Just take my word for that, because we're still kind of in the beginning. And then out here, I'm going to say comma, and I'm going to use a method called size of int. Okay, and then I need to come all the way out here and end it with a semicolon. Okay, so what I'm saying is I'm going to print the value of x so that we can see that x is in fact 4. And then I'm saying for this compiler, the number of bytes used is, and I'm saying what is the size of integer? Give me that number. Okay, tell me what that is. All right, now let's save this, Control Save, and this program is called assign. So over here I'm going to say make assign, and it looks like we got it right. So we're going to say /assign, and we get the value of x is 4, which is good. For this value, for this compiler, the number of bytes used in an integer is 4. Okay? Now, to show you what I was alluding to earlier, let's just make this %d. Okay? We're going to come back over here, and I'm going to make it. And it says error, format specifies type int, but the argument has type unsigned long. Okay? So this, it's telling me here, it's supposed to be unsigned long. All right? And I found that out when I was testing, but I wanted to show you that I wasn't just making it up. So long unsigned, save it again, go back, rebuild it, oops, there we go, and rerun it. And we're back. Now, I'm going to clear this. So we're back at the top. And I want to talk a little bit about process of programming. Notice I really have only done 1, 2, 3 commands. And I did a compile and a run. Okay? Now I have 2 pages of code to type. And I could have just typed them all in and hit go, and I probably would have been close, maybe a couple of typos. But as you're starting out and as you learn to code, if you can do a quick make and a run to make sure you're good with what you've done so far, you're building good habits. Take your program in chunks and small bites at first, and you will eventually learn to write more and more code before you compile. But in the beginning, especially in a language that is small and very, very picky, like C, it's really worth your time to take it. I've seen students be very successful literally adding a line, compiling it, adding a line, compiling it. And as they get comfortable, then they can do more and more. Because it's really easy to make silly mistakes. And if you're only seeing 1 or 2 mistakes in the compiler when it barfs at you, it's a lot less frustrating than you've got 27 and you want to give up because you don't know where to start. Okay? So that's just a little bit of wisdom, and we're going to keep going now. So that is an integer. Now there is a smaller integer called a short. And we're going to say D equals 4. Okay? And we're going to say shorts are 2 bytes in C. Okay? And here's where, again, I'm going to show you how to save yourself time, especially with these printfs. Okay? I'm going to copy these 2 by hitting Control C, and then I'm going to paste them right here, Control V, and I'm just going to change what I need. So this becomes D, right? Because I'm dealing with D, and this is D, okay? And this is a short, and then I believe that's the same because of the data typing, and so this is going to be short, and I've just done another data type that we can look at. A short is short is a type of integer, but it only has 2 bytes. So it's easy to have an integer that's too big for the 2 bytes. All right. So let's take a look at this. Let's Control Save. Go next door, and let's do make assign. Run assign, and there we go. The value of D is 4. For this compiler, the number of bytes used in a short is 2. Okay? There you have it. So that worked. All right, the next one we're going to look at is a long. Okay? So we're going to have another, let's give ourselves some lines of code here. Let's start scrolling up so I don't run off my record screen. And we're going to say long, and I'm going to start to use proper camel casing for variables. So we're going to call this my long integer type. Okay, now that's a really long variable name, but you'll notice that for variables, the first letter is small, and then every word in the variable name afterwards is capitalized, and that is called camel case. So my long integer type equals, now let's just make this one 99. Okay? And I could store 99 in any of these types. I'm just picking a value, if you will. Okay? And I'm going to say long integers in C are stored in 8 bytes. Okay? So long basically doubles the length of an integer. All right, and here we go again. I can literally swipe these 2 lines, Control C, Control V, and I can say the value of, now I got to be careful here, my long integer type is, and I'm going to need to do this again, my long integer type, and the number of bytes in a long is long. Okay, Control S, go back here, make a sign. Oops, what did we do? My long integer type, it didn't like that. Because for some reason I went back to a D here. I need a long D because I'm no longer printing. Because long is a big enough number, I need a long decimal, not unsigned. Unsigned means I'm not using the plus or minus sign, but a long is apparently a long decimal, which would make sense. So I have to fix that to match. And the nice thing about this compiler is it tells you the data type you need. Let's see, wait. LD format specifies int, but the argument has type long. The value is %. Oh, I didn't save my work. See, because I did do this, but I didn't say Control Save. So now this should work. No? The value of my long integer type is %d. Oh, I missed it here. There we go. LD. And I bet this has to go back to LU. I changed it in the wrong spot. So there you go. And by the way, this is exactly making my point for why you want to do this slowly. All right, let's go /, and there it is. And you'll see the value for my long integer type is 99, and for this compiler, the number of bytes used in a long is 8. So I'm going to clear this, so we're back at the top. Let's run it again. There it is, and go back to C. All right. Now, the other one I want to show you in integers is kind of weird because it's not an integer, but it can be treated as an integer, and that is the data type of a character or a char or a car, however you want to pronounce it. But a character C, okay, we'll set that equal to, now when you're dealing with what I call a char, it's basically the single quotes, and we're going to give this, let's just use capital A, since that's the beginning of the ASCII codes for the alphabet for capitals. All right, need a semicolon. All right, I can treat that as an integer. Okay, so I'm going to say printf the integer value of, and let's call this my char, just so that we're not getting confused with letters. So we're going to say the integer value of my char is, and we're going to need, now we're going to treat this as an integer or a decimal, or a digit, if you will. And we're going to say, comma, C, or my char. My char. Sounds like a Pokemon. Okay. There you go. But now I'm going to do this same thing again. Control C. Because that's going to print the ASCII value of that character. So I'm going to say the character value. Whoops. Somebody hit caps lock. Character value of my char is, and here I'm going to put %C. And I'm going to need my /ns, which I tend to love to forget. Okay. And I'm going to put the same variable. So what this means is I can treat a character data type as the character or as the integer value of the ASCII. Okay. Now I'm going to save it this time. And let's run make again. And then let's run it. And notice the integer value of my car is 65 and the character value is A, which is true. Okay, A on the ASCII scale is 65. So there you have it. You can treat a character as its integer value. And that is very important when we get to algorithms like the Caesar cipher, where we're going to rotate the characters around the alphabet. So A would be position 0, B would be 1, C would be 2. And if we're running a Caesar of 3, we would need the ASCII value, add 3 to it, and use that as the character in the ciphertext. So this you will find to be very, very useful as you go through particularly the Harvard CS50 curriculum. But it's a really cool trick in C or any language that you can treat a character as the ASCII value or the character value itself. Okay? So that is what we're going to talk about for this video for the integer types. Now we need to get to the floating types. Okay? So let's just delimit where we're at and say we're now going to deal with floating types. Okay? Now, a float, and I'm going to show you what I call top commenting here, and that is like this. Float, let me do this the way you would type it. Float in C is 4 bytes, and the precision is 6 decimal places. Okay? So I'm going to say float F equals 3.141592. Okay? And doubles, and I'm going to go through a couple of these. Doubles, or let's just say double in C, is 8 bytes, and the precision is 15 decimal places. Okay, so double, we'll call it FF, equals 123.4567876543743. I think there's enough places. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay? So there's 15 decimal places of accuracy. Okay? Now, a long double in C is 10 bytes with a precision of 19 decimal places. Okay? So long double FFF equals 987, and we're just going to put in 19 decimal places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay? Semicolon. All right? Because you can hold more precision without inducing errors, okay, with floating points. All right? Now, there's a couple things I want to go over besides those, and I'm not going to do a lot of printing with these. Control S. Let's just make sure that it compiles so that I didn't introduce any syntax errors, because I'm putting them in because really it's the same process. Okay, if you want to play with that, you can go ahead and do that, but that's how you would do a float, a double, and a long double. Okay, where we have a short int and a long, and then a character. The other thing that I want you to understand is basically how to set a constant. Now, a constant is a value that isn't going to change in your program anywhere, but it's a value you're going to use a lot of different times, and you don't want to have to go change it 300 places in your code. So one of the common ones that is often used is tax rate. Okay, so you build it as a preprocessor directive. Okay, and a preprocessor directive goes up at the top outside of main, and it starts with hashtag. Okay, but if I say define, I can now create a constant, and the convention for that naming is all caps. So I'm going to call this tax underscore rate, and then I just leave a space, and I'm going to say 0.07. So if my tax rate now, because these are preprocessor directives and not commands, they do not need semicolons at the end. Okay? But I can use tax rate anywhere in my code I want. All right? And if I have to change the tax rate, I just change it here, and what is used in my code once I recompile it will be automatically changed. Okay? So what I'm going to do down here is I'm just going to say, let's print the tax rate. So I'm going to say, let's just do a printf. The tax on a, well, let's make something up. $100 purchase is, let's say percent F for floating point. Okay, and let's put this after a colon. So we're looking for a float, and we're going to say tax rate times 100. Okay, Control save. Let's see if we did that right. It liked it. Let's do a clear, run it up at the top. Oh, forgot my /n, of course. But the tax on a $100 purchase is 7.00, which is correct. And I forgot my /n. And if I only want to do 2 decimal places, I can go up here and say 0.2. And let's put the /n in here. Save that. And you can look up all of that formatting, and we'll actually talk about that in a later video. Make assign ./assign. And there we go. The tax on a $100 purchase is $7. Okay? And I could have even put in the $sign if we wanted. I could go in here and say, and I believe I need a $$sign. Let's make sure I was right and didn't introduce something weird. Yep, didn't like that. Let's just try a $sign. Guess it takes it. I was confused. All right, here we go. There we go. Now we have the $sign in there. Nice. So apparently the $sign works fine. All right, so we've added that. And so now we've used a constant, okay, because you don't ever want to have a global variable. Global variables are evil. They are not good. And the last data type I want to show you comes from the string library, or the library of CS50. This one. Because CS50 gives us the string data type. Okay, and I'm gonna prove that to you. We're gonna say string s equals hello world. Okay. Now, I'm gonna say printf. And unfortunately, watch what happens if I just try to put s in here. Okay, you'd think I could because it's printing a string. Okay, so let's just try that and I'll show you what happens. See, it barfs all over the place. It's looking for the %s for string of characters, even though that's a string. Okay, so I have to go quote %s quote, comma, S. Right? That's just the nature of C. When you get into some of the bigger languages, you're not going to have that problem. Let's clear this back to the top. Make it and run it. And sure enough, there you go. I left off the /n again. Okay, but there's hello world. All right, so let's put the /n in there again. All right, Control save. But you will notice, and I'm going to put in here, string data type comes from the CS50 library. All right, and I'm going to prove that to you here in a minute. So let's make sure that I do a make, clear. Now let's run it again. And there it is, hello world on its own line. Okay? Now, what I'm going to do to prove this is I'm going to comment out the CS50 library. And we're going to save it. And we're going to make it again. And you're going to see it choke. Okay? And it chokes all over this string S. Okay? Because it's just not, it thinks you're trying to type things in. It's very confused. It does not like string. Okay? So it doesn't like it because we did not have the CS50 library in there. So I'm going to take that out. Remake it. Now it likes it again. One more time for good luck. All right? So that's been a long video on assignments, okay? But it shows you that it's nothing to fear, okay? So go through this. You now know how to make constants that you can use over and over again. You've learned some of the placeholders that we use for the data types. We've learned pretty much the small, medium, large for both integers and floating types. And we've learned that CS50 gives us a very cool string library. All right. The other thing I wanted to show you kind of anecdotally is if you go up to the view menu, there's presentation mode and dark mode. I got to this dark mode by turning on the dark mode right there. So if you like this dark mode, that's how you get to it. Welcome back. So hopefully you've seen a little bit about the data types that we're going to use and some basic assignments. And in the next video, we're going to talk about formatted printing so that you have a little bit better idea of how to get things to display out to the console because you're going to use that a lot as we move forward. So I'll see you on the other side.